Greetings everybody, and welcome back. Thank you for tuning in again. So we're going to get into lesson 8. For lesson 8, we're going to do algebraic techniques, okay? So we're still doing vectors and scalars, okay? So the graphical method is head to tail, but then there are also algebraic methods, okay? Algebraic techniques. Okay. So now, so this is what? For vectors. This is for vectors in a straight line. This is for vectors in a straight line, okay? So unlike head to tail, sometimes the vectors are not in the same direction and they're not in a straight line, okay? So when you have head to tail, sometimes you can have vectors like this. See, the vectors that are not in a straight line. So here, you see these vectors are not on one straight line like that. So they are moving at diagonals to each other. So in this case, so when you have vectors like this, that's when you can use head to tail. But then when you have vectors in a straight line, that's when we must use algebraic techniques. See? So we're going to learn about algebraic techniques in this lesson, okay? So this is what we're saying. We say whenever you are faced with adding vectors, with adding vectors, acting vectors acting in a straight line, acting in a straight line, acting in a straight line. So that is so in a straight line we mean left, right, up or down. So this is what we mean in a straight line. So you can use the following method. So I'm going to break it here step by step, okay? So if the vector is acting in a straight line, so what do we mean when we say straight line? This means that this means left or right or up or down, okay? This is what we mean when we say vectors in a straight line, okay? So I want to break it down here, what? Step by step. So I want to break it down step by step. So the first thing you do, okay, if you have vectors in a straight line is that you choose you choose you choose a positive direction, okay? So you choose a positive direction, okay? So you choose the positive direction. That's the first thing that you do. So depending on whether the movement is horizontal or is vertical, so it's your choice, okay? You can say up is positive, or you can say up is negative, okay? If you say up is positive, then it means down will be negative, you see? So whatever you choose, then in this case here, it means that down is going to be positive, you see? Just that the direction that you choose, there must be consistency, even when you're doing your calculations. So the problems come when there is no consistency, okay? But then don't worry, I'll show you at this point. So, and then you add, yeah, then you add or subtract. Then you add or subtract the magnitude. The magnitude of the vectors. Of the vectors using appropriate signs. Okay, using appropriate signs. So appropriate signs. So the signs, if the signs is the negative and the positive. Okay, and then the next thing that you do, step number 3. This. So step number 3. Then you see, step number 3 is the final step. Okay, so as a final step, the direction of the resultant. The direction of the resultant should be so the direction should be included in words, okay? In words. So what does this mean? This means that positive answers, okay? Positive answers positive answers are in a positive direction and negative answers are in a negative direction. So this means that, so if you chose positive as to the right, it means that your final answer must be to the right if your answer is positive. So your final answer must include words, okay? Depending on the answer that you find, you see. So let's do an example, okay? Let's do an example so that you can see what we mean here. So let me repeat the steps again, okay? Choose a positive direction. So whatever, you can say to the left is positive, or you can say to the right is positive. You can say east, or you can say west is positive, okay? So then you add, or you can subtract the magnitude of the vectors using appropriate signs. Using appropriate signs, they mean that whatever direction you chose is positive, then it means all the vectors that go that way will be positive, and the vectors that move in the opposite direction will be negative, you see. So, and then at the final step, the direction of the resultant should be included in words, not in signs, you see. You remove the sign and you put words. I'll show you how you do it. So positive answers are in a positive direction and negative answers are in a negative direction. So here is what's going to happen. So let's do an example, okay, so that you can see what we mean. Happening. So now let's do example 1. And then we're going to follow the steps that you just saw. So you can copy the example here that we're doing. So we're going to do an example here together. So they say here that a man applies a force of 5 newtons on a crate. Okay. The crate pushes back. The crate pushes back on the man with a force of 2 newtons. Force of 2 newtons. So, and then they say calculate algebraically. Calculate algebraically the resultant force that the man applies to the crate. Applies to the crate. So here is then what we're going to do. Okay. So the solution here, okay, is gonna be so the first thing so we choose a direction. That's the first thing to do. We choose a positive direction. Choose a positive direction. So there is a force of 5 Newton that goes to the right, and then there is a force of 2 newtons that goes to the left. So we're then going to say this is positive. So meaning that to the right is positive in this case, and to the left is negative. So that's the direction that we chose. So this is the positive direction, meaning the opposite direction will be the negative direction. And the next thing that we do, so you add, okay. The second step is you add or subtract the magnitude of the vectors using appropriate signs. So, meaning step 2, for step 2, we're going to say 5 Newton plus negative 2 Newton. Okay. So this is going to be, from mathematics, this is positive multiplied by negative. So it's just going to be 5 minus 2. Okay. And then it's going to give us a 3 newtons. You see? So this is a positive 3 Newton because there is no negative sign here. You see? So this means that because they're asking us to calculate the resultant force. So this means, remember, they say the resultant should be in words, you see, not as a number. You don't say negative or positive, you must use words, you see. So we're going to say, therefore, resultant force, okay? So the resultant force in our case here is going to be 3 newtons to the right, okay? To the right, or you can also say 3 newtons east. To the right is the same as east. You see? So this is what they mean. Your resultant force, the resultant of the vector should be in words. You see, if we had a negative here, you see, if we had a negative, then we would say 3 newtons to the left or 3 newtons west. That's what would happen if we had a negative sign here. So the words that you write here are obtained from the answer that you get. You see, the whatever answer that you get here, this is what gives you the words. You see step 3 here, what it says. Step 3, you say, as a final step, the direction of the resultant should be included in words. Positive answers are in a positive direction and negative answers are in a negative direction. You see, this is what we mean. You see, I forgot to write step 1 here. This is step 1 here. This is where we choose the positive direction. So this should be step 1. You choose a positive direction before you do anything. It helps to give the reference here. So let's do example 2, shall we? Let's do example 2. So let me write down the statement here. For example 2, let's get into example 2. Example to here. Yes. So now, for example, 2, the statement says, suppose a tennis ball is thrown horizontally is happening now. This is suppose a tennis ball is thrown horizontally towards a wall. Say towards a wall at an initial velocity at an initial velocity of 3 meters per second. To the right, to the right, I don't know. Guys, I'm sorry about that. It keeps acting up. I don't know. Maybe there's a technical problem here. So to the right, and then after that, what happens? They say after striking the wall, after striking the wall, after striking the wall, the ball returns. The ball returns to the thrower at 2 meters per second. And say determine the change in velocity. The change in velocity of the ball. So the tennis ball is thrown horizontally towards a wall at an initial velocity of 3 meters per second to the right. After striking the ball returns to the thrower at 2 meters per second. Determine the change in velocity of the ball. So they want the resultant, you see, if they want the change in velocity. So we must find the resultant velocity here. Okay, so yeah, this is so let's go to the solution. So step 1, you must choose the positive direction, okay? So we're going to say to the right is positive, okay? So it's positive 3 meters per second. It's positive 3 meters per second. So if to the right is positive, means that to the left is going to be negative, see? So it's going to be, because they said 3 meters per second to the right, so it's going to be 3 meters per second. And then it's going to be, so to the left, it's going to be negative. Let's make it smaller. So to the left is going to be negative 2. It's this. Then it's going to be 2 meters per second. And then step 2, we must add, okay? We must add the 2 magnitudes, but then with the appropriate sign, see? So it's going to be 3 plus negative 2, which is going to be 1 meter per second, which is a positive 1 meter per second. And then step 3, which is the final step, we must write down the resultant, and it must be written in terms of a word. Okay, so this means that the change in velocity in this case is 1 meter per second to the right. Okay, because that's what we chose here. Our answer is positive, and that's the positive direction is the right, isn't it? According to step 1. According to step 1, when we were choosing direction here, see. So when we were deciding on direction, we said to the right is positive and to the left is negative. And then we added the magnitude of the 2 vectors with the appropriate signs. We got the answer. That answer was positive. So meaning the change in velocity is 1 meter per second to the right. The resultant vector must be in words. But they can. So let's leave it here, okay? Let's leave it here for lesson 8. Okay. Let's leave it here for lesson 8. Leave your answers, leave your questions in the comment section. Leave your questions in the comment section, please. Let me know if there's something you don't understand, and I will address your questions, okay? Guys, thank you for tuning in again. Thank you for tuning in. I'll see you on the next one. I hope you tune in for the next lesson. Bye-bye for now, and please stay focused. stay focused and and work hard.